Hello and welcome back to my another video. As you might see, I'm right now showing you the goal of this tutorial. Right now I already completed it, but my goal is to walk through what I did, why and how. Well, basically the idea is to create an environment to make financial trades using the Python and more focused into the future to user reinforcement learning in doing some kind of market actions in finance. So I'm just showing you the environment render that the goal is to make to help us continue development of this kind of project. And right now this is only a first tutorial video for the following project, and this will be a little different because right now I'll continue developing this as a project, not as a tutorials. This means that I'm not publishing separate files for each tutorial that I'm recording, and on each recording I will continue working on the same stuff but improving, changing, adapting things that would work for me better. So if you would like to continue or to step to the files of some of these tutorials, I'll update the README file somewhere here on the tutorials, and I'll add some kind of explanation how to get these files. And this means that on GitHub, I'll make a text-specific versions where I created these tutorials, where I stopped, and where I continue working on. So this means that, for example, third tutorial, I'll record third tutorial, and there will be a lot of new stuff already implemented, and means that what I'll show you in this tutorial might not work, or might it work, because I'm not sure what I'll be changing yet. But at first, before walking through where to begin while trying to create this automated trading in finance, I need to create some explanations for you, because this is some first tutorial. So I'll open an image. I made a simple explanation graph, what is the goal and how it should look like. So here on the left side, you should see that there is some kind of live data feeder and data feeder from disk. And in lighter and in dots, this means that I haven't implemented this in this tutorial, but there is a goal in the future tutorials to implement this. And walking through these tutorials, I'll try to update these kind of graph, how it will work and what whole structure, how it works. I'll try to explain this more in code, but the idea is that usually when we are training some agent, we need to have a data, and usually we use a historical data to train our agents, and later we'll use this train agent on historical data for live actions, live trading, for example. And I'm not telling you that I will successfully make a profitable trades with this whole stuff, but who knows? My goal is to try it out and give you something to go on, to work on, develop, and maybe, who knows, my project will grow to something bigger in the future. So also, what we have when we have our data on disk? Well, we have open, high, low, close data for each time step. And we can make a state object from this data. And we feed this data into some kind of simulation trading environment that we open. For example, we take 100 time steps from history, and we use these 100 time steps to predict what will be action or price in 101 step. So that's the goal. And usually when we are making these trades, we would like to include the indicators, but I'm not drawing it right now because not the goal is here. I'm not yet sure in what step I should integrate these, so I leave this for next tutorial. Also, we would know our environment should know the assets. This means the balance, how many assets we have, how many balance we use to trade, and how many is on order, etc. But also, this is not implemented in this tutorial. And what we are interested to do is, when the simulation works, we are interested to render this simulation to see where our agent makes these actions, whether they're good, whether they're bad, and whether our implementation is correct. Maybe we implement something wrong, so we could see this through render. And another step that we do is that usually we need to do some pre-processing or word calculation or etc. Assets change to know what are the results from our previous action. So this means that I'm not fully implement this, but I already partly implement this, so I'll show you this. And so what this means, when we have trading environment, the same as in our real trades, we, for example, place an order to buy. So we are interested to know what are the results from this buy, how our assets change, how many we bought, and whether in next step we are in a profit or in a loss. That's all these steps that we will try to get. And when we are talking about machine learning and artificial intelligence, usually the open, high, low, close prices might not work for us. So this means we might need to pre-process this data. And this will be done somewhere here, but I'm not really sure here. But when I'll be 100% sure, I'll make changes accordingly. So when we get this data, we feed this data into our agent that makes an action: buy, hold, sell, whatever. And also we feed this action back to trading environment where we place this action, and we receive these results, and we do this over and over and over. And for example, at some point we want to train our agents from our historical data, whether we did a good profit or we made a loss, and we want to train our agent so in the another epoch or episode it would make different actions. And of course we want to save all our data from our actions somewhere to logs, so we could go back to look and evaluate how it was training, what was the reward, and etc. So for this, we'll be using the TensorBoard logs, and also along we might save our train agent, so we could use this in our testing or live trading. So that's a short introduction about the idea, and let's move on to the code. So I have here it running, but I need to close it. So where to start? Usually it's the hardest stuff is to know where to start when we are creating something. And I decided that a great point to start is somewhere with data that we could predict. So for example, I could use a live data, but at the beginning it would be really hard to develop, because when we will start training our model, it's really hard to know whether it's possible to make a profitable actions or trades from such data or not. So to make it work better, I decided that I'll create a sinusoidal data, and this data we'll use to work on our whole environment, models, rendering, and etc. And why I used a sinusoid data? Because it is predictable. It's kind of easy to learn where we need to do some buy actions, where we need to do hold, or where it would be good idea to sell. So I decided to do so. And it's a good option to test whether it works or not, because definitely our agent should learn to trade the sinusoid data. And for example, if we would feed our model with random data, it definitely shouldn't learn anything from it, because the random data is unpredictable and it should be impossible to make profit from random data. So that's our goal when we are starting our project. So let's go to the create sinusoid data. I'm not explaining everything here step by step, but the idea is that I'll try to use some large data, because after this sinusoid stuff, I'll try to make orders or cryptocurrency, maybe on Bitcoin data. So I need to show that my data is pretty large and not between 0 and 1. So also I would test some kind of preprocessing techniques. So you might see I have this kind of function. I'm not going step by step what it has and what it doesn't, but the idea is that it creates open, high, and low and close prices and timestamp. And I can look at this data that I created with this data. So it has timestamp, it's a date, so this data is with 4 hours difference. Each candle is after 4 hours. And there is open, high, low, and close. So we can plot this data. So I run this, and we should see our plot. Let's maximize it. And as you might see, that's not the full data, it's only the last 100 timestamps. And you might see that it is definitely sinusoidal and not identical. It has some noise, and that's perfect for our tasks. And that's exactly what you were seeing it rendering. So we will try to do everything on this data. And I could use some zoom, and you must see it's kind of noisy. And I'm plotting here only the close prices because we are not interested to see something else. So great. So let's close it. And you remember I told you that we need to create some data feeder that we feed whether from live data or data from our saved data, for example, right now from this CSV file. So I have this playing.py script here that I started working on, and you might see that I have this data feeder. I read it with this into data frame, and there is the Pandas data feeder. And if I open this kind of file, there is a requirements that this data frame should have timestamp, open, high, low, and close in the columns. That's a requirement. And when I create this as iterator, this means that I can iterate it over full data set, and it will return me the state. And that's exactly what I was showing here, open, high, low, close state. And it has the timestamp, open, high, low, close, and of course it has volume. I'm not sure if it will be necessary for us, but right now I have it. So the idea is here that I can use it whether in iterator or get everything by index. And I'm returning this state object. If I go to the state object, it's pretty simple. It requires to have this kind of special timestamp format, and we are going to work with it. Okay, I'm returning this data state, and I can actually iterate it here. So I write for data in data feeder, I write pass, and I can run this in a debug mode. Let's run this, and you might see I have data, and it has a date, high, low, close, open, timestamp in a string, date, time format, and etc. And everything is just fine. And I can use right now this data in my trading environment. And I don't need this anymore. I can close it. And what is the idea here is that I'm creating this trading environment, and when we are trading our agent, we can't train it on identical data. This means, for example, I have 10,000 timestamps, and my trading loop shouldn't look like this because I need to split this, for example, into 10 parts, also into the test part. If my whole data set was within 10,000 steps, I stick it as 1,000 steps in one episode, in one game, for example. And I picked this 1000 randomly from this 10,000 indexes and picked this 10,000 steps. And I traded on these candlesticks, and I train the agent on these 1000 steps, and then I do this again with a trained agent on another 1000, and I iterate over and over, and this way it will learn it. Well, at least I think so, because it's only first tutorial. I'm not sure where it will went, but idea is clear. So let's go into my trading environment, and there is several main functions that we have to have idea on. So I will be relying on OpenAI GYM environment. That's kind of special reinforcement learning environment that used to train reinforcement learning agents to make an actions to learn to play a game. For example, to land a lander or learn a walk. And I already created a few tutorials about that, and you can look at my channel and to check it out how I learned this. And I created this reinforcement learning model that I teach to do so. So the idea is to use the same principle to play around and interact with this environment to learn to making a profitable trades and to make actions that gives us the most profit. So the idea is that I create this object, and it must have a step where we apply the step, for example, buy, hold, sell, and we receive another step after this action. This means how our reward changes, how our assets changed, whether it increased or decreased. And from these results, we'll be able to calculate reward, and whether it was a good action, we give a reward to our agent, and if it was bad action, we'll punish it. And this way it will learn. Also, we need to have a reset. For example, when my agent finished 1000 steps, it needs to have a reset. And it will go to another 1000 random indexes. Also, it has render and close, but I haven't implemented them yet. So the idea is here that I will return everything from my environment into the dictionary. So I will know what my observations were, what my assets are, and so on. So mainly, I'll use this info to render the environment. And observation is simply a step, at least for now, but we'll need to make the pre-processing it. So this idea is that we'll need to use these observations to train our agent. And also, we'll use reward for training, these for training, info is only for additional data. So we'll use this for render. And we have a reset and etc. Yeah, I calculate the index, where to start and etc. And we are iterating this data feed, whether it's live or whether it's from file. Well, it should be iterated the same way. Well, at least I think right now the same way. What the action space are, it will be 3 action spaces. This means hold, buy, sell, or do not. And that's it. And I haven't implemented this yet, but the idea is that I will. And first, I wanted to implement everything correct to get the render environment and etc. So let's go to render. I haven't implemented it here, but I implemented it separately. And I'm just finding the structure right now. What's the best way to do so? So here is my Pygame render. And this my packages will be called FinRock. Well, why I decided to use it? FinRock, it's financial rocket, and my name is Rokas, so I decided to combine this. That's only the idea. And yeah, so well, I have a Pygame render. Why I called it Pygame? Because I use a Pygame package to render it up. And you might see I imported like this because I don't want this to package to make it dependable on Pygame. So you would need to install it, because my idea is that, for example, we have this render right now in Pygame, but maybe you would like to render it in OpenCV or in Matplotlib, or even in some kind of Flask API on the website. That will give us some flexibility in our render type. And of course, when we are running the training, we don't want to render it because it takes a lot of time and resources to render, so that's a waste of time. But we are interested to look at it when we are testing it. So the idea is that I'm making this color scheme that I can change, and I decide what the window size I use, screen width, screen height, and etc. All the sizes, frame rate, and etc. And I simply render it. And the idea is that I feed this dictionary into this render, and that's it. And we have a render. And when we are stepping into another epoch, we need to call Pygame reset. So the environment would know that it needs to reset everything. So if I go here, there is my render. And I simply draw everything with a Pygame. And because this is not a Pygame tutorial, I'm not going to explain it here. And mainly, the idea why I'm recording is that I want to teach you how you can create an environment from scratch where you could make your orders, teach it to make finance orders, and etc. And this is not the finance advice that take it, use it on real data, and you'll win the million. No, it's not. It's only for educational reasons. And here I have a pre-render. That's a decorator, you might see, and it's responsible for handling Pygame window, and render is only front end, what I draw, where I draw, and etc. And this one handles the frame rate, quitting events or resizing events, if that data type is correct, etc. So basically, that's what I wanted to show you. And if I'll run this again, let's run this. You might see it works. And it reads the data from my random sinusoid CSV file, and it draws everything here. I can resize it, it's up to me how it works, but I implemented this resizing stuff into the functionality. And it's right now only 10 FPS per second rendered. And you might see it's pretty quick, and our data is pretty random, but that's the idea, to make it random. And yeah, what else? I don't know. That's only the first tutorial. Keep in mind that I'll continue working on it, and if you would like to test this out, there will be a documentation, some kind of explanation how you can get the code that I am showing you right now, because probably you're looking at this later when I release a new versions and code is totally different. But to understand everything from scratch, you need to start from the beginning, because I'm not going to explain everything step by step. I tried to create this kind of first release to make it as simple as possible, to make a backbone for further development. And if you come later, you might see that everything is pretty complicated and it's really hard to understand what happens where. So I'll upload here the documentation, how and where you can check my code of this tutorial where you can download it and etc. And you'll be able to open some questions on GitHub, or maybe you would like to join this for this development of this project. I don't know, but the idea is here to work on it. And this is only the first tutorial to demonstrate to you that it works. And I think that it's possible to make a profit from this reinforcement learning trading in finance, and we'll see this. I'll continue working on this project, and that's it. And this was only the first introduction tutorial to show you what is my idea, where I begin working on it, and etc. And these package requirements are only NumPy, Panda, and Matplotlib, at least for now. Later I might add more of this, but we will see. So thank you again for watching, and I believe we'll see you pretty soon when I'll make a second tutorial, what I changed and what I improved. So thank you again for watching, and we'll see you next time. Bye.